Okay, so make sure you wrote down your learning goals. So we're going to be just doing basic parts of a circle today, but probably all new information for you, most of it. So the definition of a circle is just a set of points around a center. So a set of points that are equidistant. What do we think equidistant means? What do we think equidistant means?
They're all the same.
The same what?
Distance.
Distance. So it's just equal distance or the same distance away from a given point, which is our center. That are, I forgot the word are, that are equidistant from the center. Okay, we also name the circle with the center. So I'll give you the center name here in a second, but that's just, we would call it like circle A. I'm going to give you the letter A. So we would name that circle A. You name the circle by the center. Okay, so our center is A in this case. Just going to be doing some different examples, just making up some letters. No rhyme or reason to that. Also, if you have colored pens or pencils, that would be a good option for today because you can color code all these different vocab. Okay, so our center is the point that is going to be equidistant to the circle's edge. Okay, and that's where our radius comes from. But again, a circle is just why we use like a compass. It holds our radius from the center and makes sure it's the same distance all around. Okay, let's go ahead and move on to chord. So chord should be a new term for you guys. A chord is a line segment, so does that mean it goes on forever, or does it mean it has a start and a stop?
It has a start and stop.
It has a start and stop. It's just a line segment. So this is a segment with both endpoints on the circle. So let's kind of review back to like Unit 1 stuff. We have to remember how to name segments and lines and things like that. But it is important that we know a chord is going to start and stop on the circle. Okay, so let's come over here and draw a chord. So I'm going to just pick 2 points on my circle. And I'm just going to make up some letters. So M and N, just because it's fun to say, M and N. Okay, and please use your ruler. I don't want to get the ruler out here, but you use your ruler so it's nice and straight. So this is our line segment starting from M and going to N, and that is our chord. So we see it only stays on the interior here. It's not going to go outside of the circle. Okay, and then we would name this just by the 2 letters. So what would we name this chord? MN. And what do we need on top of that MN? Not a line, but a line segment, so no arrows. Okay, so going back to like super basic stuff here. Okay, so let's move down to diameter. A diameter is a type of chord, but where is it going to cross through? Where's that chord going to cross through in the diameter? In the center. Good. Can you see this color? Can you read that color? Okay. So this is a chord that passes through the center. It is also the longest chord because it is going through the widest part of our circle. So it is a chord that passes through the center. It's also the longest chord. I also know the diameter is 2 times our what?
Radius.
Radius, so I'm going to write that down here as well. So our diameter is 2 times our radius. Okay, we recognize diameter with like the lowercase letter d, But when we're naming it, let's go ahead and draw our diameter. I'm going to do mine horizontally. It doesn't matter what direction it's going as long as it's the line passing, or sorry, the chord passing through the center. So I'm going to name this C and D. And with your ruler, we want to pass through the center A. And I'm going to move that in a little bit because that looks confusing. It's because you're a genius.
I actually am a genius. Young philosopher, I like to say.
CD. And make sure it just looks so much nicer when you have a ruler and colors. It just looks beautiful. Okay, so that's our diameter. How would I name that diameter? Steven. How would you name the diameter? We want 2 points if it's a line segment. CD, very good. And we need our little line segment over it. Okay, circumference, we already went over this, but what's the definition of circumference? What's the definition of circumference? It's the distance where? Around the circle. And what did we say our equation was for circumference? We'll write it down here. Equation for circumference? Pi times diameter. Good. Okay, we're not going to draw a picture of that, but just know it's going to be that distance all the way around. So basically our perimeter. Okay, and last thing we're drawing on this picture is our radius. The radius starts from what point?
The center.
Starts from the center and goes to where? Does it
The
matter?
outside edge.
Yeah, anywhere on the outside edge doesn't matter. So this is our distance from the center to any point on the circle. On the circle. Okay, we recognize that with a lowercase r, but let's go ahead and make one. So I'm going to do a F. A F. Okay, we're not going to do the definition of area, but go ahead and write down, see if you can remember the equation for the area of a circle that we did on the do now. Brayton, do you remember the equation for our area? From our do now? Pi, do you remember the rest? Okay, here, do you remember the rest? Good, pi r squared. That one, to me, I don't know why, but it's just like, it's easy to remember. Pi r squared. Just like rolls off the tongue. Pi r squared. Okay, and then the r stands for radius there. So we're not going to do a definition or a picture, just make sure you know the area of a circle. Okay, moving on to our next circle, we're going to start drawing our lines. So the first type of line we have is a tangent line. What's the difference between a line and a chord? Good, so our line is going to keep going forever and ever and ever with our arrows. A chord is going to stop as a line segment. So our tangent line is a line that intersects the circle at only one point. And we should recognize the word tangent as one of our trig functions. When we did sine, cosine, tan, this is that function again. secant is another trig function that you'll do in Algebra 2. So we're actually seeing those on circles now. So it intersects at one point. So I'm going to pick that one point on the circle's edge. What point do you want to use here? Anyone? Pick a letter.
C and F.
Okay, so C. We'll pick C first. Okay, so that's going to be the point where my line is touching. So let's go ahead and pick up your ruler. You want to just like literally brush up against the side of the circle. You're not going through the circle at all. It stays on the outside. So mine's a little bit more difficult to draw because I don't have a ruler, but make sure you line it up like that. It just touches the outside of the circle. Okay, make sure we have arrows because it is a line. We need those arrows. And then Aiden said the other point we wanted to use was what? F. So that just doesn't matter on either side. We just have to name a line with 2 points. Okay, so I would name this CF. And what symbol do I put on top? A line. Good. So we need our arrows. So think tangent is 1 point. Tangent is 1 point. How many do you think secant will be? 3 points. What comes after 1? 2.
There's 2 there.
So this is going to be a line that intersects the circle at 2 points. So tangent intersects at 1 point, only on the outside, never through the middle. A secant is going to cross through the middle at 2 points, so let's pick our 2 points. Oh, and then I remembered I forgot something about tan. Doesn't matter where you put those 2 points, but let's make it not the diameter. Dylan, give me 2 points. A and B. Okay, so with your ruler, this actually looks like a what? What did we do on the earlier circle? Looks like a chord, right? If I just started at A and stopped at B, we could call it a chord, but if it is a line crossing through, then that is going to be our secant. And if you don't have colors, you can just like label your lines like that. If you don't have colors to color code. Okay, Mason, how would I name that secant? Name that secant. Good, AB, and what do I need on top? A line, so we need our arrows there. Okay, so that's the difference between tangent and secant. The only other thing I forgot to mention, this point where it touches the circle is called our point of tangency. Point of tangency. So the point where it touches at 1 point is our point of tangency. Okay, and our last circle is reserved for our arcs. Arcs. What do you guys think an arc is? What does it sound like? Yeah. Like think of an arch or like a little baby rainbow, but that is the symbol for an arc, just a little piece of my circle. So I'm just going to draw like, I'm not going to name it or anything, I'm just going to show you what an arc would look like. So that would represent an arc, and we'll name those in just a second, but it is literally just a piece of the circle. And it's a piece of the circumference, so not just like a segment, like a piece of pizza or something like that, but it is a piece of the circle's edge. We should have a pizza party when we finish circles. You guys can find the diameter, the area, and the circumference. It'll be so fun.
Only the kids who get A's on the test get pizza. So that's how you make it a pie instead of an F.
Yeah, I've never made pie, but
It can't be that one.
can't be that. Okay, So we have, it breaks down into a minor arc and a major arc. Which one do you think is our big arc? The major one, but let's start with minor. So what I drew is called a minor arc because it is in between 0 and 180 degrees. So an arc in between, are you guys okay with that abbreviation? Between? Okay. In between 0 and 180 degrees. So it is going to be smaller than half of a circle. Okay, I'm going to write a 2 next to minor arc, or I'll put that in parentheses. We have to write a minor arc with just 2 letters. Someone give me 2 letters?
Z-Y.
Ooh, yeah. Take it to the end. Okay, so Z and Y, we would write this as arc ZY or YZ, doesn't matter. But we have our little arc symbol up above. – 0 degrees and 180 degrees. Okay, anybody remember what a semicircle is? That should not be a new word. It's half a circle, so how many degrees is half of a circle? 180, very good. So this is an arc of 180 degrees. An arc of 180 degrees, also half a circle. Okay, so I'm going to pick 2 more points here to put on our circle. And I want to make sure that's at a diameter. So make sure those 2 points are right across from each other like a diameter. And just make sure, so draw yourself a little dotted line to make sure we're splitting that circle in half. X, W. That's going to be weird because they're not in order, but that's okay. Okay, so we can name a semicircle with 2 points or 3 points. So for example, I could do like XW because does it matter which direction I go there? No, we're still going to end up at the same point. So it can be XW with our arc. I can also write it with 3 points, and more of the time you're going to see it with 3 points. So I'll put a box around this one, but it could be, so we read it in the correct direction, so you have to start at X and go through another point. So I would do like XZW. Even if there's like 8 points from X to W, we only need 3, so just pick 3. We want the starting and the stop to be the same, but I could have used Y or Z in the middle. But this shows you the direction, so I have to start at X, go through Z, and end at W. So direction does matter with arcs. But I'm going to put a box around that one. That is more of the time you're going to see it with 3 points too. Okay, and major arc. What do we think a major arc is going to be greater than? Yeah, greater than a semicircle. So this is going to be with 3 letters always, and this is an arc in between 180 degrees, and what is a full circle? 360, good. I'll write that down at the bottom, so the total is 360 degrees, like when you do a full spin. It's a circle of 360 degrees. Okay, so I'm going to pick one. I'm going to start at Z, and I'm going to go all the way around to X. So that's definitely greater than 180 degrees because I went past 180 degrees there. So I could start at X and go that way. So if I did that, I would start at X, pass through W, and end where? I went all the way back to Z. I could name it like that if I wanted to go in that direction. If I wanted to go the other direction, I would be starting at Z. I would pass through, I'll say Y here, and I'm ending back at X. So the direction does matter here. I'm going to write that off to the side. You have to follow the letters in order. So that gives you your start, your next one, and your stop. So it gives you the direction there. Okay, so I'm going to pause here before we start on the back and do some examples. I'll let you guys have a second to talk and ask me any questions. Okay, so I already did the first one for you. That was 1, the radius. I'm just going to skip through and do a few before I let you try them on your own. Let's find the diameter. Where do I find a diameter? It crosses through where? The middle. So I know it's this line right here. So we're looking for a combination of D, A, and E. So does anyone see that combination? Actually, always this the diameter is going to have like the start and the stop. So we're looking for DE or ED. What number is that? 7. Number 7.
What? Oh, there's
yeah, it's matching. It's matching. Okay, let's skip over to tangent. I know tangent crosses the line at how many points? Look at your notes if you're not sure. Tangent intersects at 1 point. So does anyone see where that is? Here's my 1 point. It's going to be this line over here. So we're looking for a combination of those letters, and I heard someone already say it. CB with our line over it. What if that had a segment symbol? Would that be correct? No, it has to be a line. So that is number 3. Let's do the major arc. How many letters does a major arc have? 3. So I'm really choosing between DEF and DCE. One of them is a semicircle, one of them is a major arc. So let's see which one is which. Let's do DEF. So what point do I start at? D. Then I go where? E. And then I go F. Is that a semicircle or greater than a semicircle? That's bigger, right? It would have stopped at E if it were a semicircle. So number 2 is going to be our major arc, which means number 5, let's double check that, is hopefully our semicircle. So where am I starting for DCE? I start at D, I go through C, and I end at E. Is that a semicircle? Or half a circle? Yeah. So that would be 5. Okay, a minor arc, you don't even have to look. How many letters does a minor arc have? Minor arcs have just 2 points, so where is that one here? Number 8. Good. Okay, so I'll pause here and let you guys try the rest of those with your partner. Okay, so hopefully you tried those. I'm not going to put up the answers for those, but check with your vocab. Next one. Next one, you're going to have to do a little bit of math. So it says circles A and D have radii of 4 centimeters and 1 centimeters respectively, which means that circle A has which radius? 4. So that means circle A has 4. So I'm going to go ahead and label radius, radius, radius. Wherever I see a radius, I'm going to put 4. We're going to do that with D. What's the radius of D? 1. So wherever I see a radius, 1, 1, 1. Just labeling a radius. All that's happening. Alright, so it just wants us to go through and list out some lengths. So BF, what would I do to find B to F? Yeah, it's just 4 plus 4, which is 8 centimeters. That's actually our what? What does that represent? That's the diameter. Good. Okay, A to D. What would I have to add from A to D? 4 plus 1, which would give me 5 centimeters. Okay, C to D. I have this little piece 1, but do I have any information about the outside here? We don't know that yet, but we do notice that it gave us a right triangle here. Yes? Very good. I heard someone say Pythagorean. I know that I can use a squared plus b squared, equals c squared here. Which one am I looking for, A, B, or C?
You're looking for B.
We're looking for A or B, right? It doesn't matter. Let's just say that we're looking for B. What's my A value? 4. What's my C value? 5. Good. So we added 4 plus 1 there to get 5. If we went through the whole process, we'll do that. Anybody remember the 4 blank 5 triple? The 3, 4, 5 triple. So it will be 3, but let's just go through it. So that's 16. That's 25. I'm going to subtract 16. I get b squared equals 9. And what's my last step? Square root it. So b does in fact equal what? 3. Which gave me the whole side that I was looking for, C to D. So that is equal to 3 centimeters. So this is building off of like our prior knowledge using Pythagorean here. So CD is 3. From C to D, we found that whole side to be 3. So CG, very good. CG, what would I do to find just this little piece here? Subtract 1, so I get 2 centimeters. And what would I do to find the perimeter of my triangle ACD? Add up all the sides. So I'm adding up, what is this side? 5. What is that side? 3. What is that side? So I'm adding up 3 plus 4 plus 5, which would give me 12. So these are questions that's using like prior knowledge, mixing it into our circles. That's a pretty simple example on your homework. I'll let you skip the really difficult ones, but I'll tell you which ones those are. Okay, last 3, we're just drawing the lines that they want us to. So grab your ruler again. That's supposed to be a circle. I think I changed all the rest of these to lines for you. Okay, so we're just going to draw the line that they're telling us to draw. So secant line AB intersects circle M at points A and B. We name the circle by the center. So if this is circle M, and sorry, that's supposed to be just a circle symbol. If it's circle M, where do I put the M? In the middle. That is the name of my circle, which therefore is the center. Okay, a secant line is going to stay on the outside, or does it cross through the inside? Cross through the inside at 2 points, so it doesn't matter where you put your 2 points, A and B. I'm just going to keep mine simple. And is this a line or a segment? It's a line, so use your ruler and cross through it. That one is our nice, easy example there. Okay, our next one. It says we're on circle R, so where do I put R? In the center. We have 2 lines intersecting here, a secant line and a tangent line. If you notice, what point do they share? M. So that's going to be where those 2 lines intersect. Let's go ahead and just start with our secant line. So MN. I'm going to draw it exactly like I did my last one. So I'm going to do M and N. This is our secant, so it's going to cross through, and it is a line. And then a tangent line intersects what? At how many points? 1. If you flip back and look at your picture, it's the one that just brushes up against the outside. So what point is it going to be intersecting at? M. So that should just be the line that just barely touches the circle there, just at point M. So yours will probably be a little more accurate than mine. Okay, and the last one, I'm going to have you actually, I'll pause here and let you try that one with your partner. We have a diameter. So is the diameter going to be a line or a segment? A segment. Good. There's no arrows there, so it's a start and stop. And then we have a tangent intersecting at that shared point. So I'll pause here. Okay, so make sure your picture looks like mine. I saw some people forgetting about the G there. We do have to add the point G on that line somewhere. And then that was circle M, so I could have added the M in the middle. You could have had the diameter going vertically. It doesn't matter that it looks exactly like mine, but make sure we had lines on the tangent and things like that. Okay, on your homework, I'm going to tell you which ones you can skip. I'll write it down here. And then we're actually gonna do 2 of just like the logic questions real quickly. So grab your homework. You're going to skip number 2, C, where it says central angles. So please skip that one. And someone's gonna have to catch up Justin and Faith with this. Your partners maybe. We're skipping on your homework number 2, letter C, where it says central angles. Okay. You can X that one out. We're gonna get to that next week. Okay, move down to, we're gonna do 3 and 4 together in just a second. Move down to number 5. Letters E and F. Those are really tricky. If you want to try them, you're more than welcome to. But they're using a 30, 60, 90 triangle there, which is like really complex. You can also skip number 6 because that goes with number 5. But if anyone wants to try that, that's fine. Okay, on the back, number 10, the last 3. So G, H, and that's an I. G, H, and I. You can skip those last 3. We don't know regular hexagons or regular equilaterals yet. Okay, we're gonna go back to number 3 and 4, and we're gonna do those real quick. Because those are just like the thinking through logically questions. Okay, number 3 says, Jeff was a little confused by the lesson about circle basics. When he looked back at his notes, he had written down that radii and diameters of circles are not chords. Is this correct? Explain. So it's saying that a diameter or a radius, neither of them are going to be chords. If we think about a diameter, where does it cross through? The center. Flip your notes back over to your definition. What is the definition of a chord? Good, so my purple line is the diameter. Do I have both endpoints on the circle? Yeah, so wouldn't a diameter be a chord? Yes, so that's what you can write down for number 3. Only diameters are chords for number 3. So diameters are chords because both endpoints are on the circle. This is number 3. Both endpoints are on the circle. Okay, so a radius is not a chord because it starts at the center. We don't have it. We only have one endpoint on the circle. But diameter would be a chord. Okay, you should be writing this down because this is an answer on your homework. Okay, number 4. This is kind of anyway, so a textbook has the following true or false question. 2 radii always form a diameter, true or false. It tells you that the answer is false, so let's go ahead and circle that. It didn't really care that you knew true or false there. It wants you to prove why, so just talking about proofs a little bit. I'm going to draw a picture here that you can draw also on number 4A, where it says, can you find a counterexample to this statement? So 2 radius always form a diameter. Yes, I know that the length of 2 radius is the diameter, but that's a radius, correct? This is a radius, yes? Do those 2 make up a diameter here? No, so that would be a picture of your counterexample that you can draw on number 4A. Okay, so that would be a great example of, yeah, those are 2 radius. The lengths add up to a diameter length, but those 2 specifically don't make up a diameter. Okay, and then B says most students put true. What makes this statement confusing? Why do we think that 2 radius make up a diameter always? Because diameter equals 2 what? Radius. So you can just write that there. So the lengths add up to a diameter, but they're not always going to make up an actual diameter. Okay? So the rest is up to you, except the ones that I told you to skip, so I'll leave that up here. And that will be due on Monday. I'm going to walk around and check off your homework. So have that out from last Monday.